Good morning and welcome to this webinar hosted by VTT Technical Research Center of Finland. The energy transition is progressing rapidly and it's also affecting the built environment in many ways. Today we will be discussing an important topic of future-proofing the built environment within the energy transition. My name is Kirsi Kotilainen. I'm a solution sales lead at Smart Energy and Built Environment research area at VTT. Today I have with me 4 speakers. First, Tuula Mäkinen, Green Electrification lead at VTT. Then Kari Mäki, Research Professor Smart Energy and Built Environment at VTT. Jari Shemeikka, Research Team Leader, Urban Energy Systems at VTT. And Miimo Airaksinen, Senior Vice President Development at SRV Ltd. Today we will have 4 interesting presentations. First, Tuula Mäkinen will discuss 5 bottlenecks in energy transition. Then Kari Mäki will be addressing the topic of enabling cross-sectoral flexibility within buildings. Then Jari Shemeikka will present a cost study of a Nordic residential solution, energy resilient building. And then Miimo Airaksinen will discuss future-proofing the built environment within energy transition. We will have a questions and answers session after the presentation, so please actively post questions in the chat. We will also have polls during each presentation, so please participate and we will discuss the results after the presentations. With this, I would now like to invite Tuula Mäkinen start with her first presentation.
Thank you, Kirsi, and good morning, everyone, or good afternoon and good evening, depending where you are. So, and welcome to this webinar also on my behalf. So, the energy transition, so it progresses rapidly already within our society. So, for instance, companies, they are going full steam ahead towards the growth opportunities that the energy transition creates for new technologies and solutions. But however, there are several challenges to overcome. But on the other hand, there are solutions under development for these bottlenecks. And at VTT, we carried out a kind of a strategy or vision work on identifying this kind of a major bottlenecks in the energy transition, and then we identified our that kind of solutions which we are then developing by ourselves and with our partners for overcoming these bottlenecks. And we prepared a publication on this work and presented 5 major bottlenecks and then 3 solutions for each of those. And I'm presenting that work very, very briefly. So those 5 bottlenecks which we then selected to be the major ones. So at first, so the new dynamics which we are now facing, it challenged the operation of the energy system. So with higher shares of renewables, the generation side becomes more dynamic, and at the same time, there are new kinds of dynamics introduced in the consumer side through kind of electric vehicles, heat pumps, batteries, also increased electrification in industry, and that is setting a new requirements for system management. Then conflicts between the sustainability impact. So the climate change is the biggest challenge of our times, and in many cases the actions that mitigate the climate change, they are also good for other environmental and social systems as well. But that is not always the case. So sometimes the impact can be very contradictory, and mitigating one problem may cause severe harm for other systems. The loss of natural habitat has been emphasized recently. And then this new kind of a integration and complexity in energy systems, so that is also challenging our energy resilience. So for instance, the increased dependency on the electricity, so that also kind of brings problem to the resilience. So and on the other hand, so the energy system is vulnerable to different threats and events. So there can be a service interruptions and also energy price fluctuations. And then what is discussed quite much at the moment is the limited availability of critical materials, which then slows down the energy transition. So when we are introducing a new renewable energy production, so then that increases this demand of critical raw materials, and their current production and the investment plans for the future production is not yet ready for accelerated energy transition. And then the fifth bottleneck. So what we decide today, that will impact future generation. We are talking about a path dependency. So that what has occurred in the past typically persist because of resistance to change. And on the other hand, we still have a lot of existing infrastructure that is not envisioned to play a role in the future. But it would take an enormous amount of resources, materials, energy to rebuild that whole infrastructure. And so this challenges the transition both economically and environmentally. But on the other hand, we also don't know exactly which solutions will then eventually be viable in the future. So we will only have to learn during the transition. And then to today's topic, so the built environment, so in fact it plays a pivotal role in solving these bottlenecks. So if you just think about cities, so for instance in the European Union, so they take only about 4% of the EU's land area, but on the other hand they are home to about 75% of the EU citizens. And in the cities, we in fact consume over 65% of the world's energy and account for more about than 70% of global carbon dioxide emissions. So the cities and then buildings in cities, so they are really, really important. So I have listed here of those, altogether 15 solutions which we present in this publication. So 5 ones which has a direct link to built environment, but of course also the other ones. In other ones, the buildings and built environment have a major role. And we will hear today more about a couple of these solutions or topics. So if we think about that dynamics of the energy system, so we need a so-called sector integration to provide better systemic efficiency and collaboration between different energy carriers and energy use sectors. And buildings can contribute to that by providing a flexibility and to provide a flexibility and of course also energy efficiency. And for instance, building they can act as a energy storage for improving energy flexibility. And then I mentioned earlier the ecosystems, nature ecosystems and biodiversity. So then well, we are able to design or plan our neighborhoods so that they could maintain or restore biodiversity. And then well, we will hear today more about resiliency. So there are ways to design and build the districts and buildings so that they support recovery from abnormal incidents. And then I wanted to also highlight the evidence-based decision making. So the energy transition, green transition, so that is a complex problem. We need a different kind of a solution, so both technological and systemic solutions, technologies, new services, and to be able to make a kind of right decisions. We also need a new way for decision making. And then I just would like to advertise that our publication that is available in our web pages for. So thank you for your attention.
Thank you very much, Tuula. And I think that we are ready for our next presentation. So I would like to invite Karimäki to continue with his discussion.
Okay, thank you very much. Just a moment, I will take out my slides. I hope that's full screen now. So my name is Karimäki. I'm a research professor at VTT, working on the area of smart energy systems, and I'm really speaking here about how to utilize cross-sectoral flexibility within buildings and also cities. So let's see. Just for a background, I mean, Tuula already mentioned something about the role of cities, role of buildings within the energy transition, but it's really an important player in this picture. So as said, of course, cities are the place where different things and different sectors really come together. And this is also the place where citizens are also part of the energy transition, so to say. So we have there like mobility services, we have communication, we have buildings, of course, we have all actually services of society in the same place. So that's an important location in that sense. On the other hand, buildings alone consume something like 40% of the energy globally. If you think about cities, it's even higher, as we already heard. And actually, there are quite many interesting let's say potential for flexibility also within the buildings themselves. So we see things like heating or air ventilation or different kind of water related, district heating related solutions. So actually a lot of things that could be utilized more flexibly towards the energy system and energy market, and that's very interesting. On the other hand, we are speaking much about energy efficiency and flexibility within the buildings. But of course, we must remember that the buildings are actually made for living or working or whatever. And it's important to be able to improve living conditions, maybe awareness on own energy use and so on, while also working on this energy efficiency and flexibility options. So the development is, of course, going towards digital twins and we are doing that also very much on our side. And this is really an exciting pathway for new, more data-based service models. And just the final point here, it's always important to keep in mind that the actual use of the building, actual comfort, actual safety must never be compromised, whatever we optimize or provide flexibility from the building. So our research that is kind of linked into this topic, we are working on the demand response, we are working on virtual power plant schemes, and just to simplify, virtual power plant can be called like a collection of distributed flexible assets that can be controlled as one entity towards the market or towards the grid. And of course, there are kind of two technical requirements for this. So we need to be able to monitor these assets, and we need to be able to control these assets. And that's fairly simple as such. But of course, it requires that we have like systems, we have the connectivity to different kind of assets so that we can control them. And whenever you go into smaller and smaller unit sizes, this will be more challenging because it must also be, of course, cost efficient to control them. So we have been looking at the flexibility options within buildings. I was already a bit speaking about this, and there was also something in the intro. But as said, much more dynamics is now seen in the energy system, and also the consumption side must contribute into the flexibility. And there is true value on the markets arising, and it can be seen that if you are operating large fleet of buildings, this will become like an additional value chain in the future to be able to control that for different kind of markets and take out the benefits there. Of course, the key challenges I was already mentioning, when you are going into very small scale assets like a single heating unit or whatever, you need to be really cost efficient in reaching that unit. So no massive installations should be used there. And as I already had in the first slide, of course, ensuring the actual primary use of the building and not compromising with that. So we have been looking at sub-aggregator models. So we are assuming that there are actors who already hold a portfolio of distributed assets, and they also know the primary process or primary service, and also they already have like a backend system for communication and control towards the devices, and they also have the customer in their portfolio, so to say, but they are not really active on the energy market at the moment. They don't have balanced responsibilities and these kind of factors. And of course, we have some examples here. EV charging operator is very typical such case. Heat pump providers, we have actually already commercial services emerging on this area. Different kind of building manager systems, that's really developing area. But actually, when you start to think about this, there are many areas in the society where you can find this kind of things. So there are remote connections for maintenance and monitoring, but not really like an utilization in terms of market flexibility, for instance. So how our model works. So we are kind of introducing like a new actor in a sense. So we have like a market, like an aggregator towards the market or towards the grid services, and then we are kind of introducing the layer of sub-aggregator or like a technical aggregator who has the features that I was already speaking on the previous slide. So they do have the backend system for monitoring and control the devices. And there are different kind of those units, of course. What is important here is that this is not only like a technical model. Actually, the technical solution is kind of small part of this. And instead, we are working on the business model side. What are the market rules? What are the logics for for responsibilities, who will allocate what, and so on. So there are actually a lot of things, and going into the level of contracts also, who has the final contract with the final customer, and so on. What is the model for sharing the economic benefit also towards the final customer? So these kind of things we are working on very much at the moment. And as I said, this starts to look so that this is very applicable on different areas of the society, also of course within buildings. This is just like examples, but there are some important areas we are then looking at, like how on the left hand side, how to share different responsibilities and benefits. For instance, who takes care of which process. On the other hand, in the middle part, what is the actual interface? This is now from the EV charging case, but there are different ways of doing the actual interface, whether you're installing something more or whether you are opening or selling your back-end system to an external operator to some extent. So different logics, and we are looking at different opportunities maybe there. And of course, on the right-hand side, then you need to understand the primary process. Again, here we are speaking about EV charging in the example, but you really need to understand what is happening there in real life then. So we did this kind of a study. This is already a couple of years ago, but in our campus area, we were testing different interfaces, and with with different companies, as you can see. And we were actually using our own office building also for piloting, and that's actually quite well equipped for this kind of testing, because we have a lot of sensors, a lot of controllability in our own office. I already spoke a bit about this, but this is really important for the building case. So of course, it depends on what kind of flexibility we are speaking about. If we are speaking about longer term controls, we can be in, I mean, if we do, for instance, optimization of the spot price on an hourly level, then we can do things with 1 hour time steps. That can already be quite a heavy if we speak about heating or ventilation or cooling. So that can already maybe start to be seen somehow by the final user. On the other hand, we are also speaking about different kind of reserve markets, frequency container markets, where we are normally in time steps of some minutes normally. So it can be 10 minutes or 15 minutes, or even it can be like seconds only, like very short durations actually. And now the point is exactly to look at within the building what are the possibilities and which can be matched with which kind of market, so that we can do like reasonable combinations. This is important. And this is maybe not done fully at the moment. And for the sake of this, the controls that we are normally taking are quite conservative, so to say. So we are really careful in utilizing the potential within the buildings. And this is actually where the digital twin can bring in a lot of value. So more like real-time awareness of the status of the building, more like accurate controllability, so we can go on a more local level in controlling different parts of the buildings. And then of course we have a lot of really advanced functions like human thermal models, for instance. We are also running in our own research platforms different kind of AI algorithms and so on to forecast how it looks from the user perspective, for instance. But generally, if we have a good digital twin, we have better awareness while we are doing things, and we have better support for planning the actions we are taking, and exactly matching these with different kind of markets and their requirements. I was already speaking about our office, so I will go this pretty quickly, but this is our new office building. Actually, we have already like a second part of that building open as well. in Otaniemi, in Espoo. We are collecting a lot of data. We are monitoring different parameters. We are able to control a lot of things. And everything is brought into our own research platform. And that's like our own play field for this kind of, all these topics. So we have things related to machine learning. We have, as I said, digital twin. But we also put a lot of effort on how to visualize the data, how to present the results, and so on. But these are really kind of cool things they're running there, predicting how the building will be behaving and so on with AI systems. Okay, this is just like another slide about the visualization and also user interface side. So different kind of KPI indicators, different kind of map presentations, 3D models and so on. So a lot of different things there. But I will skip that. Yeah, just to conclude, as I said, there is a lot of potential for flexibility within the buildings. But on the other hand, buildings are also kind of challenging because there are the individual users and they have different feelings about their comfort, for instance. So it's also kind of sensitive in that sense. Buildings are also quite diverse. So there are different kind of buildings, different kind of uses. But on the other hand, if you look like at a bigger mass of buildings, then it gets starts to be more and more similar and more predictable when looking at the whole building fleet. Yes, building management, building automation, that can be the shortcut, so to say, into this kind of sub-aggregator model. And I will also already speaking about digital twins. As a final note, as I said, these different kind of flexibility options, these different kind of sub-aggregator roles, they can be found everywhere when we start to look around. So there are pumping stations, there are different kind of heating or whatever pressured air stations where you have some kind of a buffer, and you also have like a remote connection there. And these are really interesting places we are currently looking at. But this is it from my side now. Thank you. I hope we can also continue the discussion afterwards.
Thank you very much, Kari, for your interesting presentation. And now we have had already 2 polls to the audience. So let's see the results of our first poll. Tuula, would you like to comment this?
Yes, thank you very much. Okay, now I see the results again. Yes, so it's for me it has been really difficult to kind of distinguish the importance of each of them, because they all seem to be very very important. But this is really interesting. So that this my little the conflict between sustainability impact. So that was a winning one.
Thank you, Tuula. And then we had the second poll was about the main challenge for utilizing building level flexibility on markets and for grid support. So Kari, would you like to comment these results, please?
Yeah. I'm sorry I missed the poll introduction during the presentation, but yes, indeed. I mean, I was maybe picking here the most typical challenges seen. And let's see, I have the results now. Okay, I think this is pretty much what I also think. I mean, normally the technical side, for instance, that is something we can do for sure. But I fully agree with the idea that business models, how this will be turned into economic value and everything, that's important. And then exactly the economic side, so that what is the cost of reaching these really like distributed assets That's also another challenge. So I think this is really a good answer as such. And I think all these 5 need to be addressed, of course, but I think this is a good priority given here.
Okay, thank you, Kari. And then I would like to invite Jari Shemeikka, Research Team Leader from VTT, to continue with his presentation on energy resilient buildings.
So hello everyone, my name is Jari Shemeikka. I'm a team leader at VTT, and I have a research team which is focusing on the urban energy solutions, so especially the demand side, the building stock, and so everything which is related to the heating, cooling and electricity in building stock is this kind of a topic of our research. And we have actually quite a long list of research related to the passive houses, zero energy buildings, concept of positive energy buildings, positive energy districts. So these are this kind of a background there, which have been a long continuation since 90s already. And now, maybe recently, we have been considering about this kind of a resiliency as a new topic, which is quite a seamless continuation for everything you do with the positive energy districts and positive energy buildings, for example, because the energy efficiency is this kind of a basement there, and then you build up on new solutions, all of that. So I will have today a few words about the energy resiliency, and I'm quite practical now that I'm not going into too deep in details, but I'll show you some example of what kind of solution it could mean if we are here in Nordic climate in Finland, which, well, we have something like the design temperature is -26. I don't know where the audience comes, but outside temperature -26 degrees Celsius is the one where we design our heating system, and we have made this kind of a worst case scenario. But first, this kind of a orientation of the thoughts that if we could imagine a world where you never have to worry about the power outage. So that's this kind of a baseline that you should have a building or office where you work, that everything is comfortable and safe even though the grid is down. So that kind of a mindset has been there in behind, and we have selected this kind of a really extreme solution, harsh winter conditions, for the study. But a few words about the definition, how we understand the energy resiliency. The energy resilience is resiliency is a difficult word that we need to have extra definitions with it so that we can get the understanding. So we understand the resiliency so that the building is adapted to the future disruptions, it is prepared for future disruptions, and if the disruption happens, it recovers from there. So that's this kind of a mindset, and it has it makes some design premise for what kind of building you should have. And of course, the new buildings are the easiest one to develop, and the challenging part is also the existing building stock. But today we are focusing on the new buildings. Then, what is the approach? How do you do that? As I mentioned, the major first step is the increasing of the energy efficiency, because whenever you increase your energy efficiency, the design loads and everything goes down, meaning that whenever you need some resources, they are smaller, of course. And maybe this kind of a mindset of maybe 50% energy efficiency improvement is that kind of a good basic approach, how you could, as a starting point, to use when you start to plan your building. And then the second step is this kind of a quite evident, but our buildings are not today designed like that. So, but whenever you have a so-called important end uses in the building or not so important end uses, you have to make a distinction between those. So usually in design phase, it means that, like, for example, electricity, you make the priority group of, for example, what people need most. So cooking or microwave ovens to make some warm food for themselves, storing their food, so fridges and freezers, And of course, lights are needed so you don't trip or stumble inside your house in dark. And maybe the last one could be this kind of a communication connections for you. Whenever there's an emergency situation, you need this kind of a communication, the true communication from the government and the information flow so that you know what's happening in the society. And then the third step is it's more related to the cost efficiency, that whenever you have done those first and second step correctly, actually the backup resources you need are quite small compared to the business as usual. That if you need to size a backup resource for this kind of a building, you haven't prepared at all, so that you have to deliver everything. So in that kind of sense, the cost efficiency it comes from these two steps that are in the first place. But then usually these backup resources, they can be batteries, backup generators, whatever. This kind of thermal energy storage is what you need during the incident. And then the interesting question is that how much would it cost actually? And this cost study is now related to a really this kind of an extreme season, -26, and it's an apartment building application. This building happens to be in well, not exactly, but quite a well designed, quite the same way that we have here. I'll show you the picture. This is located in capital region here in Helsinki. It's one of our pilot buildings in one of the EU projects that we have had, and the local HVAC and energy designer made a quite exhaustive study related to the cost efficiency and everything of the thermal losses and windows and ventilation system, and what kind of solutions there should be. And it's quite well aligned to this target that we have here. Maybe in this study, we made another extra simulation, which we used maybe a little bit better windows. We had this kind of really extremely good windows there. But so the location is here in capital region in Helsinki, the southern part of Finland. So we have the heating degree days here in Finland, something like 4,000. So if that number tells you something about. And this building is something like 7,000 square meters. It contains 100 apartments and about 200 people are living in there. And it has this kind of a local energy production. So ground source heat pump is there. And we had this kind of a 600 meter really deep or medium deep this kind of a boreholes for that, because in dense city environment, urban environment, we don't have too much room for the borehole fields. And then we had this kind of a low temperature distribution system, floor heating and cooling system, so that there is this kind of a system that it's preferable for the heat pump system, and of course mechanical supply and exhaust with excellent heat recovery. So anyhow, the overall thermal efficiency is something like -33% compared to the traditional one if we make a building with a business as usual concept according to the regulations. And then the resiliency target, we actually took quite a heavy target. So we had this kind of a 7 days or 1 week resiliency, and all the time during that 7 days, the outside temperature is -26. And we made this kind of a small allowance down from the typical indoor temperature is 21 when we design the buildings. And we allowed it to drop to 18 degrees so that we get maybe some small energy efficiency and load reduction from that side too. It's not that too big, but then 18 degrees is the one that you can survive and you can live here just using your, well, put the woolen shirt on and you can survive easily. And then I'll list here some examples about the cost items. What does it mean? These are not in any specific order, but as an example, the main message here is that whenever you make this kind of a resiliency, there are this kind of a small items, those are the extra costs. So on top of the existing business as usual application that we have. so that there are this kind of a 10s or 20s per square meter. This is the idea of the main message, except the batteries. So the lithium-ion battery technology seemed to be quite expensive, so that if you use this kind of a battery only for 7 days, it will have a huge cost impact, and maybe negative one, because the 350 euros per square meter is quite a heavy cost. But anyhow, the main message is that it's something like 0.3, 0.2, something like that, compared to the market price of the capital region on average. So these numbers are VID zero numbers, as an example. And then we figure out about the energy efficiency if we invest it. The typical change from the business as usual to the current really energy efficient solution, this kind of a resiliency solutions, the extra investment is something like 100 euros per square meter in the beginning of project. But during the life cycle, that if we took the whole life cycle 30 years, you of course you consume less energy, and then you get most of the money back. Actually, it's the additional cost is something like 20 euros per square meter. It's quite negligible, so it's not a heavy cost. So that something like 0.3 is the value of extra value of energy efficiency. And then what does it mean in picture that if we compare the business as usual solution and the resilient solution together in the same picture, that the business as usual, you don't have any extra measures related to the energy efficiency or prioritizing the end uses. So the loads are something like, well, the reduction what you get from the resiliency planning, so that we have a design of energy efficient and also prioritizing and grouping the end uses. So you get easily this kind of a 67% reduction to the this kind of a backup load sizing or backup resource sizing. So that makes it actually quite actually cheap. And the final numbers are something like this. If you think about the cost efficiency, energy efficiency, the prioritizing all together, the sum of all of those things, it leads to 50 euros per floor square meter, something like less than 1% of the apartment market price. So I claim that it's not too heavy or expensive, but of course it happens in the beginning of the project, and it might be because I haven't made this kind of an analysis related to the project profit from the builder point of view, that the construction company point of view. It's always some challenging that you add extra cost items there, but that's the magnitude of the extra cost related to the resiliency. So this is my final slide, and then there should be the question available for you, and then I'll try to look at that. I need to switch out this.
Thank
first.
you, Jari. Jari, we can then take a look at the results for the poll concerning the acceptable investment level for energy resilience in apartment building. And thank you, Jari, for your interesting case study. And would you like to comment these results that you should see now on the screen?
Interesting. Yeah. Yeah, I'm actually happy to see that the cost level, this kind of acceptable cost level, is something like this 50 euros. So that the major answers are there. So I'm happy to see that. So that this kind of a solution could be actually bankable. That's really interesting to see.
Yes, indeed. And
unfortunately, I don't know which kind of the audience where the business area or countries, what kind of situation you have locally there, but this is interesting to see.
Thank you also for the audience, and we will then have a chance to discuss more in the Q&A after the last presentation. So I would like to now welcome Dr. Miimu Airaksinen from SRV. She's a Senior Vice President on Development and will be discussing future-proofing the built environment within energy transition.
Thank you so much for this invitation, and it's really a pleasure to speak here, and especially after so interesting presentations which were previous. So my presentation is about construction and about the building, especially in the construction sector. Tuula was really nicely putting the perspective on the energy sector, and I just highlight a few things about, especially about the construction and real estate sector and in Finland. So we play a quite big role because 60% of the investments are done to buildings and on infrastructure. So this is really from the monetary point, so it has a huge impact where we are putting our money. And then, as Tuula was also pointing out, so we are using quite a lot of energy, over 30%, and also the CO2 emissions are originated over 30% in Finland from buildings and real estates. And most importantly is also this, that we are using more than any other industry, the virgin materials, and this is linked, of course, to the energy and energy used, but also to the biodiversity and what we are doing for the nature. So this is kind of like that the energy things are strongly linked to biodiversity as well, as Tuula was mentioning this already in the beginning as well. Then we were thinking about in our company that, well, I mean, what is then speeding our processes more? So that's why we kind of like saw that, well, it's good to tie our money really nicely to sustainability. And so basically our business, the more we save the CO2 emissions, so the cheaper the money is from our business. So this is an agreement what we did in this April. So we have tied our emissions to our emissions to our funding. Well, what this means is that we have divided our emissions and energy use to two categories. So this shows our construction site emissions. So basically, if you know scope 1 and scope 2 emissions, so this is what we have done there. So reduction of CO2 emissions. Quite a lot, quite a big amount, 75%. And this is, of course, super good. Then we are also planting each year 16,700 trees up in the north in order to do some good for the nature as well. But this is only for kind of like our construction sites. And here is kind of like where the flexibility for the energy use is quite tricky for us, because we are building in the cities, and it's quite often that we have housing and apartments next to us. So we cannot kind of like be flexible when we are using the energy, because in the night time we need to have quiet in the living areas. So that's why we are quite tied to those hours during the daytime, and our flexibility possibilities are not that big ones in construction sites. But then when we think about then the kind of like the building, our product, what we are creating, so there we have much more possibilities for the energy flexibility. And this picture just shows you how we have divided in our project, in our products or in our buildings, how we see the flexibility. So we are, of course, firstly and most importantly focusing on the energy efficiency. As Jari was also mentioning, so the energy efficiency is really the foundation there. But then in addition to heating and cooling demands, so we are focusing quite a lot also on the water use, because especially in the water, when we are using the water, so we need to heat up the water quite high, up in the high temperature due to Legionella and other bacteria. So kind of like flexibility in there, it's super important. So the less water we are using, so the more flexible we can be on that perspective as well. And then of course the wastewater amount is much smaller. So this is important for us. And then of course the integration of renewable energy we almost always have some sources of renewable energy in our buildings. Typically, it's PV, ground source heat pumps, but also other type of heat pumps what we are using. And then, of course, when we think about that, why we would do this flexibility, so it's really that this should be, of course, value for us, but also value for our clients. And what we can see now from our clients is that they really think that the energy is important, especially after last years when the energy was really expensive. So they really appreciate the flexibility in the energy demand as well. And we can see that from the questionnaires, but also from the direct feedback from our clients. What does this mean then in practice for us is that basically our target is to have a reduction of CO2 emissions by 50 to 60% in our, we call it life cycle wise buildings. And as you can see in this picture, so the yellow bar is kind of like a smaller one. So this means that we can easier get the reduction of CO2 in the energy part. And then here the components are, well, of course, the low carbon energy sources, but also the energy flexibility. Then, of course, I mean, we need to invest a bit more when we want to have this efficient buildings, and roughly, depending on the building type, but it roughly from 3 to 10% is the extra investment. And here, actually, it's super important when we are thinking about the investments. So we are quite a lot calculating many scenarios about the energy use, and especially on the peak power energy use, because the peak power is, of course, directly connected to how we are designing our system and how big kind of like power need we need from our system. And that's the higher the power need is, then of course the more expensive systems we have. So there also it's kind of like this really pays back also in the investment phase, also the energy flexibility in especially in the system level. And then of course, I mean, this leads to reduction of life cycle cost, roughly according to our calculations, 25 to 35% of the cost, and most of these cost reductions are really about the energy cost, where it goes, some of the material cost as well. Well, I mean, then of course, I mean, we need to think about how we are doing our business, and this is our recent study, and this is not only from our recent, but also JLR and CBRE. They have found similar kind of like results. So what we can see that in those buildings which are energy efficient, they are using less energy and they are sustainable in the long term as well. So we can see that the green premium in the sale varies kind of like just under 10 or just over 10%. So this is extremely good and important thing. And also the healthy building premium is rather high as well. Directly also we can see increase in the prices when the renewable energy sources are integrated in the building. So then the value of the building is higher. And of course, super important, especially in other than an apartment building, is the rental rate as well. So in green buildings, the rental rate is higher than typical ones. So this shows really that it's not only kind of like for us where this is good business, but it's for our clients as well. Here are a few examples what is then in the practice. So the left side picture is a office building, and the right side picture is a multi-purpose building. So basically meaning that there is library, sport facilities, and other purposes in this building. This is located in West Coast, Finland, and it's owned by the city. And there are actually two ways how we are working in these ones. Typically, in those city-owned buildings. So we kind of like give the cities the possibility as well. We can stay there 20 years with you, and we then manage the maintenance services, including the energy services. And here our business model is that, well, if we get low energy use and still kind of like the indoor conditions and user satisfaction is good, so then we get some profit and we are sharing the profit with the owners. Or, well, if we are not in the target line, so then we need to pay the penalty. So really kind of like making us and motivate us to do our best in the whole maintenance period. And the recent kind of like what we have seen here is that actually usually when we are staying there in the building and managing the building in the long term, so usually the users, they are more kind of like satisfied, they're happy for the conditions, and also they can give us the direct feedback that how this building should work, and also the cost for the energy is lower. So this looks really good from that perspective, that not only one is winning, but really both sides are winning in this type of building business models. Well, then when we think about then kind of like, because the world is of course not perfect yet, so what we need, especially for the future, is that we need even more kind of like smart and really resilient systems, because currently we are quite a lot kind of like we are relying in our resiliency on the grid, and we can do some optimization inside our buildings, but we don't have typically storages in the buildings. Well, for the heating, this is not that big problem, because typically buildings are massive, and we can kind of like cut down the heating for 1 hour or even sometimes bigger time, and the people won't get that bad conditions, thermal conditions inside the building. But then of course for the lighting, for ventilation, we need to get of course our systems to run in order to get the acceptable conditions and comfortable conditions for the users. So there we need kind of like not only the building systems, but also for kind of like blocks of building systems, in order to kind of like manage the system optimally and not only sub-optimize one building, but really and that's of course more cost efficient for the buildings as well. So really optimizing the area, not only one single business. And then super important is the forecasting and understanding how people are behaving in the buildings, how they are using the buildings, when they are using the buildings. And that's why we need these forecasting and adaptable systems. And of course, we need to use new algorithms to understand that even better. This is one way where we need, of course, more research, and the systems are developing more and more. Thermal comfort is probably my favorite topic. VTT has actually developed a super nice system about individual thermal comfort and how we can plug in that type of like systems to control the heating and ventilation in the building. And this is like something new and innovative compared to normal, where we are only controlling the heating based on the outdoor temperature and indoor temperature. This is kind of like where we can really gain a big gains, especially in respect to flexibility. And then, of course, buildings are not a single system, so we need to understand the other systems as well. And for example, electrical cars, but also, for example, shopping centers, schools, how they need to use the energy and how we're optimizing not only our building, but the whole system of buildings. And actually, most importantly, I mean, we have already quite advanced building automation systems, and of course, energy systems have been really advanced already a long time ago. But especially the kind of like the connections and linkages, so how we make sure that we have the data privacy and cybersecurity issues in control, because this is quite a new, especially for the building industry. We have been kind of like focused on the building level systems, but now when we have more and more interfaces, so this is extremely important that we are focusing on these ones. We have actually in our industry, so we have now collected a new paper about this cybersecurity. So we are really focusing on it, that we won't risk any data or privacy issues. And then, of course, most importantly is the users, that how we are taking that into account, the user preferences, because of course we are individuals, everyone. So, and we prepare different conditions. So how we are taking that into account, that people still feel that they have the control, and that, but still kind of like we can optimize the single, not only the single one, but the whole system. So this is one where we need to have more research in the future as well. And as large, so when we're building these buildings, so they have a long lifespan. So it's not only, well, 30 years is the technical one for the systems, and for the structures is 100 years. And of course, we hope that the buildings are there more than 100 years. So that's why we need to really be flexible, not only in the energy system, but also in the layouts, because we are building for the people who have not even yet born. So we need to give them the good conditions, and that's why, of course, the sustainability is so important topic as well. So I would like to thank you for your interest and listening, and this, I'll stop sharing my presentation now.
Thank you very much, Miimu. And I think first we can take a look at your poll results. That your poll was concerning the most important topic on future-proofing a building. And here are the results. And Miimu, would you like to take a quick look and comment from your own point of view?
Yes, thank you. I mean, this is actually, I mean, a bit, I mean, I totally agree that renewable energy and low carbon energy is important, as we can see in the poll that this was almost over two-thirds about the results. And that's, of course, I mean, the key and the foundation, what we need to have. But then, of course, energy resiliency and cybersecurity are extremely important as well, that otherwise we are ruining kind of like the good sustainability focus if we don't have those in the place. But good answers. Thank you for being active.
Yes, and thank you so much for the audience for answering the polls. And now it's time for us we have about 10 minutes now, so we can take some questions at the end of this webinar. But first, I want to thank all the speakers for excellent presentations. Very, very interesting and important topic that we are discussing today. But yes, so let's take some questions. We can start with the questions now from our audience, and I think there are at least a couple of questions there that we can take. So I believe that there's a question about for instance, about the role of artificial intelligence in combination with greenery and renewable energy. If I translate this correctly now into English. So would someone like to from the speakers like to comment this question concerning the role of artificial intelligence?
Well, I could start. So yeah, so I could start with kind of a data evidence-based decision making. So of course the artificial intelligence then offers as a skill for having that kind of tools for decision making and planning that which are then able to take account a kind of a different elements of the kind of a socio-ecological issues. So the environmental issues, social issues, political, legal, technological. So that came into my mind at first.
Thank you, Tuula. Anyone else?
Yeah. Can I continue? I mean, from the point of view of the whole transition. I think the role of, let's say, forecasting, both on the generation side, on the other hand, on the consumption side, that's really getting very important asset for the future. Also better like a profiling, and that's also a bit related to forecasting actually. So building like profiles for different kind of PV panels or consumers or whatever. So I think AI is exactly good in this kind of appliances, learning how individual users or individual producers are kind of behaving with different kind of within different kind of circumstances. I think that's an important part. And then if you think about the energy system a bit more widely, I think there are a lot of places like maybe not so visible, like but maybe even like old-fashioned things like maintenance, asset management. I think AI can do a lot of things there also, kind of running in the background and finding like something we wouldn't normally maybe see. So those are maybe what I have been thinking about.
And if I may just kind of like quick comment, I mean, I think this is really good. Kari was pointing out that really for the technical things, AI is super good. But as Tuula was pointing out also, so we have this political and social things and where we have the values. So, I mean, AI is super good for helping us, but then we, of course, need the humans to make the value-based decisions.
Thank you so much for these answers. And then let's take also another question from the audience, and I think that's about like how to what is the kind of the potential and also the timeline for using materials, let's say in the building floors or ceilings that can store energy in buildings, but also in the roads and different places in the built environment.
If I may kind of like, I mean, I think Jari also have a good perspective on this, but this is like there has been a lot of research in this field and even piloting kind of like phase change materials and kind of like really how we're using the buildings as storages. And this is super good. But at the same time, so we really need to be kind of like having a really good control system in a way that it's in the same pace, because otherwise we risk that it might even use more energy. But maybe Jari, you know the best results for the recent research.
Well, we haven't been researching that too much lately, but then according to my knowledge, these solutions which are related to the collecting and harvesting and on the surfaces there, I see the solar energy is one, of course, but then thermal, this kind of inertia and storing as like a mass, like a concrete or something like that, the daytime at least, it's so that during summer or maybe springtime we get something, but when we go to the winter, well, the free energy of sun is not available. So the Finnish climate is, we have some three month period which is total darkness almost, so that's actually the challenging part from our heating and energy harvesting point of view. And wind energy is there during the winter, but usually we can't use that in the urban environment. There are some issues related to that.
Thank you, Mimo and Jari. Then we got a comment concerning the system integration. So system integration, improved energy efficiency and building resiliency. Are these going to be market-driven processes or are government subsidies necessary? So any comments on this?
Yeah, at least my point of view is that I hope that at the end this will be, of course, market-driven things, and I really believe they will be. But then on the other hand, in the early phase, role of piloting, role of doing like new kind of solutions, that's also something that need to be supported. And now, especially these things, they are like let's say systemic solutions, so that there are different kind of actors coming together as bigger solutions, so to say. So definitely I see like support for piloting needed at this point. But at the end, I guess it needs to be commercial in any case.
Any other comments from?
Maybe I could add, because I spoke about the energy resiliency, and if we make a resilient solution, well, I claim that you get when you make a resilient solution, you get the flexibility free of charge. That's my statement. Of course, there are details related to that. Kari knows those details, but that's actually this kind of way if you want to make it easy.
Okay. Thank you. And then we also, concerning Jari, your presentation, we got a comment on that 7 days and minus 26 degrees and comfort. So I think this is like, is it really possible? And how would you then actually implement this kind of a required level of energy efficiency in buildings to achieve this?
Well, the comfort question is maybe I wasn't clear enough, but I mentioned there as the during this, when we made the simulations, we used the 18 degrees. It's not that warm, but you can survive. But in longer perspective, if I'd make this kind of a novel solution, I'd add this kind of a individual control for each of the apartments, even each of the rooms. That was in our study also as an assumption that we have this kind of a room level control. But in the future, maybe I would make a distinction between the different people groups. For example, elderly people, they may get the 23, 24 there if they want to be in a safe. And maybe younger and more healthier people could have this 18. So that could be maybe the final application of this kind of a thermal comfort, so that it's user specific, who is there to get the correct comfort. But this study that I showed, we used this kind of an on average 18 degrees there. But comfort is a good point. Thank you very much for the question.
And I think that there's still one more question. On a global scale, how advanced are we here in Finland in the energy transition in built environment? And are there some cities we can learn from, and which ones? Quick answers from...
I mean, from the whole energy system point of view, we are quite advanced in all the automation and metering and everything. Then especially in integrating, let's say, electricity and district heating side in Finland, we are quite advanced. So in this kind of Nordic, let's say Nordic dimension, we are quite good, and we would have a lot of things to also bring to other countries, I would say. That's a quick comment.
Thank you.
Please, Mimu. Yeah, sorry. Some addition, kind of like that also in the building level. So our building system automation is actually quite advanced compared to, for example, European scale.
That's true.
Thank you. We could definitely continue discussion much longer. We have some more questions in the chat. Maybe our experts will be able to answer them in the chat for the audience, but we now need to unfortunately close this webinar, and I would like to thank the audience for actively asking questions, very good questions, and also once again thank you for all the presenters for your excellent presentations, and thank you so much.